Hello, everyone. I'm Ryan Berry,
I'm Matthew Puckett.
and welcome to the very first episode of Cloud Simplified, where we're going to be presenting some ideas and methods of being able to use cloud computing, trying to distill down some of the complicated components that exist for you to leverage for building out workloads in the cloud, and try to provide it to you in a meaningful and simplified way. So, nothing else to add? I guess So I work as a cloud solution architect at Microsoft, where I engage customers on how they can successfully use Azure for being able to address particular business problems or scenarios that they may have. And the goal of this entire series is to share some of those ideas and insights that we have in working with customers with you, our audience, to be able to understand how to effectively, or I should say more effectively, be able to make use of Azure for your business.
And just like Ryan, I do the same thing. And it's one of our customers' definite needs is to have technical advice. And so we're here to help you with that. And we know that cloud can be certainly confusing sometimes, maybe challenging, or sometimes downright intimidating. But we're here to help make that simplified for you guys, and we're looking forward to getting started.
Yep, absolutely. So alongside this program will be a website. We'll provide some blog entries and periodic updates and different insights with activities we have going on with customers. The website's cloudsimplify.io. Today we'll be talking about some enterprise uses for Azure Storage. So we're taking a fairly simple concept and elaborating on how it can be used to solve some fairly complex problems that some customers may have. Without further ado, let's dive into highlighting what storage is, what types of capabilities it can be leveraged for in the context of enterprise computing, and how it can be extended to be able to solve some more challenging problems that maybe some customers like you might be facing. Might be a hold up or bottleneck for moving a workload that you may have into the cloud. So Azure Storage is a fairly simplified capability that at its core allows you to store stuff, and that stuff could be simple things like files. It could be a little bit more complicated things like name value pair type data, and using Azure Table Storage. Or if you are building applications, there's also Azure Storage is used for the queue capability. But Azure Storage is also where the disks reside for virtual machines that you may bring up for compute-related purposes. And the benefit of having this unified capability in Azure is that you can access all of these things that are stored within Azure through a unified API or through a unified management plane. And by that I mean using things like the command line interface or through PowerShell, REST APIs, a variety of different access methods that you have for being able to access any and all of these types of things that are stored in Azure Storage. And if you're not already aware, Azure Storage also has some physical redundancy extended to you by virtue of the fact that a single item stored in Azure actually is stored in triplicate. So let's say you have a disk backing a virtual machine. We actually store that 3 times in a synchronous manner in one of our Azure regions to protect you and insulate you against any sort of failures or transient issues that we may have with hardware that might be in our data center. So the read reliability is extremely high. So in fact, actually, I've knocking on a lot of wood, I've not heard of any customer ever who has lost any data using any of these storage capabilities in Azure.
Hey, Ryan, so I got a question for you before we get going too far.
Sure. Yeah.
So one of the things that comes up a lot of times with my customers is they often ask me, do I need to create a stripe inside my virtual machine, i.e. a RAID 10 or a RAID 5 of those disks in order to create data protection? So I tell them no. Actually, they cause themselves more trouble. What's your take on that?
Yeah, I'm absolutely in agreement with you. The only situations where I've run into customers benefiting from having multiple disks is for spanning, creating Windows storage space volumes where you actually are spanning volumes across multiple spindles. And there are some inherent performance benefits from doing that as well, but it's not for being able to, or it's not for the purpose, rather, of being able to provide, the redundant array of inexpensive disks as you would have may have, done in the on-premises world. Yeah, good point. And just to provide some really interesting statistics, Azure Storage has hundreds of trillions of objects and is actually is able to scale, or has scaled to many tens of millions of transactions per second. So it's a very scalable platform that we have millions of customers using around the globe for all of the boxes shown here on the screen.
What's interesting to me, though, Ryan, is I get a lot of times architects inside those companies who constantly give me arguments about why cloud storage isn't going to be fast enough for virtual machines or their particular workloads. So, what I really find a lot of times is sitting down with the numbers. Do we have some numbers that we can share with these guys, or just some things off the top of your head about how fast this actual storage is? Because I know when I've seen it, it's unbelievable, right?
Yeah, absolutely. There's a couple of different. That's a really good question, and then there's a couple of different ways that you can use, what Azure Storage, and the one that you're referring to is over here on the left-hand side in the context of using it for disk storage. And a storage account, actually a standard storage account in Azure, has a throughput limit of 20,000 IOPS per second, which sounds like a low...
Wait a minute. You're talking about storage accounts? What are storage accounts? You're going to have to explain this to me, too, because I think our customers, right?
Right. So that's a good point. So a storage account, think of it as a vessel or container that you can put any of these blocks into. And a storage account can actually have a mixture of all of this stuff, contained in a singular place. And it's kind of, think of it as a management boundary, management plane of assets that customers want to store. And it's quite typical to have multiple storage accounts for backing disks. And in fact, we have some ways of being able to store or to back disks, rather, with using something we call managed storage, which is actually an altogether different topic. But essentially what that means is that we abstract away the notion of a storage account. So so when you think about a disk, having 20,000 IOPS, a storage account having a 20,000 IOP throughput limit, and a standard disk in Azure has a 500 IOP, is capped at 500 IOPS, and we'll talk about ways to get eke more performance out of that to answer your question. But if you think about that, if you put 45, 50 disks in a storage account, you're oversubscribing the I/O throughput that your account can provide. Yep. And we unfortunately had customers doing that. I mean, they weren't really, understanding of the limits of Azure Storage services or of storage accounts, and they would do that. They might start off with a handful of VMs, and their footprint in Azure would grow, and lo and behold, they start experiencing blue screens or random reboots, and it's strictly because the operating system is waiting for an I/O event to complete, and it times out, and the kernel panics, and things go downhill really fast.
All right.
So managed storage takes the context of a storage account out of the equation, and all a customer has to do is say, I want a new virtual machine, and that you have the option of picking, if actually the default is managed storage, and we'll go to the portal and we'll walk through that. And when you're using managed storage, that we actually create, we being Microsoft, create storage accounts under the covers for you. So we prevent you from oversubscribing a single storage account.
So that sounds like, we should be going into managed disks rather than unmanaged disks. Is that right?
That is why it's the default behavior in the portal for any new virtual machine being created. You can override that behavior for some scenarios where maybe you want to conjoin disks that you already are using in an unmanaged account. And there's also some things with managed disks today that make it a little bit more challenging to move that disk from one Azure region to another. So there might be some reasons why customers might want to make use of their own storage accounts, but the default is managed disks. So and to go to your question, so I said 500 IOPS, 20,000 IOPS for a storage account, 500 per disk, and customers can actually provision, premium storage is one way to actually get additional performance. I think you can get up to, 80,000 or so IOPS for, some of our higher-end premium disks, and that's on a single drive. Another option, and you talked about RAID earlier, is that you can actually take multiple disks, multiple 500 IOP disks, and combine them together into one singular volume, and Windows or Linux operating system, and actually be able to have many magnitudes better performance by striping that data across multiple LUNs, if you will.
I think one of the times I usually get in trouble with a customer is, they've spun so many disks on top of it, and they're getting really bad performance, and so we're going through a number of different troubleshooting efforts, right? And then we come to find out, we either didn't pick the right size disk, or we don't have the right striping type across them. So that's great information. Appreciate that.
Yep. No problem. So there's actually some alternative options. So what I talked about is directly attaching a disk to a virtual machine. In the on-premises world, it's not uncommon to have SAN environments where maybe solid state back disks that are being mounted on virtual machines, as the boot volume or data volume, backing workloads running on those virtual machines. And you can actually do that in Azure as well. We have some vendors like NetApp, who provide appliances that you can actually deploy into Azure, and some cloud native appliances such as Nasuni, where you can actually you can actually point those appliances across many storage accounts. So if you recall, I said there's a limit of 20,000 IOPS throughput for a storage account. And if you can point Nasuni at 5 storage accounts, that's 100,000 IOPS of throughput.
Oh, I got you. Yeah, so that's cool. Yeah.
So in fact, that's going to be the scenario I'm going to talk about for a customer of mine who actually did just that, and actually was able to outperform their on-premises, very expensive solid-state SAN, by switching to that sort of architecture in Azure.
Oh, the poor storage guy.
Yes. Yeah. All right. So, the previous slide talked about all the different types of stuff that can be in a storage account, and this is now clicking down into just blob storage. So this is just storing binary data in a storage account, whether that be files that maybe an application is writing to persist, maybe from a web application, or data backing some other, line of business application.
When you're sitting there talking to customers about this type of stuff, do they typically embrace this type of storage? Do they have a lot of common knowledge for it? Because a lot of times when I talk to my customers, we talk about blob storage, and I get kind of a puzzled look, a little eyebrow raises up a little bit. So, I don't know, do you find that that's typically the case, or do you find that your app developers are really more in tune with this? And do we have to make a shift through the IT culture, the silos?
That's actually also a really good question, and it is something that is I would say a cloud-specific nuance. So if you're talking to somebody in IT operations that's more familiar with LUNs, iSCSI LUNs, and virtual disks that might be sitting on some large host environment that they have, the concept of blobs is foreign. It's that's sort of a cloud vernacular. And certainly these two on the left, block and append blobs, these are the types of blobs that would probably be used more so by an application developer or some sort of script or some sort of line of business application where you have to use APIs to deposit files into into a blob storage container, or which in the container, think of that as a folder that's sitting in a storage account, which we just talked about on the previous slide.
Okay.
The one that's more applicable to the IT-centric workloads like running virtual machines is the page blobs. These are specialized blobs that are optimized for random access. So exactly what a disk is. So this is actually how the virtual hard disks are persisted inside of a storage account.
I see. Okay.
All right. So this is actually where this is my final slide before we jump in over to the portal and we'll walk through some examples. We introduced some new capability that actually allows customers to do what's called blob tiering. So if you think about storing files or even virtual hard disks, as I showed on the previous slide, the page blobs. So there's a cost associated with every byte of data that's actually being housed in our storage environment in Azure. And that's the default tier is the hot blob, which means that the actual act of reading or writing data, the transactions that are occurring against accessing that data or updating that data, appending that data, the cost is very low. But the storage account cost is a little bit higher because this is data that's readily available. We have infrastructure in place to make it very responsive. Honor our throughput that we advertise. But there might be some situations where you don't need that level of throughput. So think about backing up, medical records data or tax or accounting data that you have to retain for some period of time. So typically, when we're working, the customers I've worked with, they have, loads of data that kind of fall into this sort of classification where, where it's not, they want it to be readily accessible if necessary, but it doesn't need to be, doesn't need to be sitting on an environment that is, incredibly responsive to, respond to requests. So in Azure, we actually took a different approach than some of our competitors. We have this notion of hot and cool. And the performance is the same.
There's not. No.
Yeah. So we have some fairly large competitors that have some appropriately named SKUs for their products. One referring to large blocks of ice moving through the ocean.
I don't know who you're talking about.
and the throughput of that storage is to the tune of days or weeks to actually retrieve that data.
Just like a block of ice, right?
Yeah, exactly. So our cool blob storage is actually the same throughput, 20,000 IOPS of throughput as hot storage. But what the difference is that we actually you actually incur additional costs for a transaction. So a transaction, again, as I highlighted earlier, being that operation to request your retrieve data or to append or write data back. So that's sort of the penalty that you have for retrieving that data, but it's much less expensive to actually house data there.
So how secure is my data? You talked about taxes, right? That's a very secure, very sensitive type of information. I'm sure like guys in the healthcare, additional finance or retail or manufacturing, data is very sensitive. We talked about all this storage stuff, and tell me a little bit about is there encryption available? What kind of protections do we offer? Because I think I spend more time too once we get past can storage actually support my workload to is your storage secure?
Yeah, so that's actually an excellent point and something that does come up with a lot of customers I've talked to as well. So by default, when you enable or when you create a storage account, or if one is provisioned on your behalf using the managed disks that we'll explore a little bit when we go in the portal, by default encryption, at-rest encryption is enabled.
Okay.
So every block of data that's written to Azure Storage is encrypted, and there's an additional measure of security you can actually enable to always require data to be secure in transit. So by that, under the covers, anytime you're accessing Azure Storage, you're doing it, if you're using like a command line interface as an example, or a utility that we'll look at called Azure Storage Explorer. It's actually, at the end of the day, there's a REST API that's actually being invoked and hit by those access devices to retrieve and put data into Azure Storage. And you can actually forcibly disallow SSL related transports for being able to read or write data to your storage account.
I like that word, forcibly.
Yeah. Yes. And this is actually something else that we're very transparent about, and we allow customers to tour our facilities. But when you're writing when you're writing data to a storage account, or let's just use a virtual hard disk as a simple talking example, your data is not sitting on one disk in a data center that somebody can walk up to and pull out and access. Yeah, your data is scattered across hundreds or potentially even thousands of physical disks in a single data center.
That's going to be a lot of disks.
yeah. So you think about the fact that minuscule fractions of data is physically written to a disk, and it's encrypted at rest. And the individuals who are potentially replacing disks that have gone bad, there is a complete separation of duties between the individuals working physically at the data center, racking and stacking equipment or replacing bad drives, and the individual who has logical access to be able to identify that customer X's data is on this container spread across these LUNs. So there's no awareness whatsoever by anybody within our physical facilities who have any idea what's stored on those drives, and moreover they're physically shredded and destroyed before they leave our facility. So
that's great. Okay.
Yeah.
Awesome.
All right, so let's jump over to the portal and check out how some of this works.